Today we are going to begin lesson 1 of chapter 3. As you can see, we are going to be talking about integers and absolute value today. Okay? The essential question that we're going to be using or looking at as we work through chapter 3, as you can see here, says what happens when you add, subtract, multiply, and divide integers. As you know, chapter 3 focuses on integers, and so we're going to be looking at the different ways we can add them, subtract, multiply, and divide them. Okay? One thing that you are going to want to complete as we work through lesson 1 is also on your vocab map. You have the specific vocabulary words that we're going to be tying into the lesson today: integer, negative integer, positive integer, graph, and absolute value. So please make sure that as you're working through and finishing reading through lesson 1, you are also filling in these 5 words on your vocab map. Remember the definition from text, and also 2 examples of each of those. Okay, let's go ahead and get started. As we take a look on page 191 in your book, okay, your book gives you a definition of integer. So you can see here it says numbers like 5 and negative 8 are called integers. An integer is any number from the set, and they give you your ellipsis, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and so forth. Please remember that these 3 dots mean that it's going to continue. So for example, okay, you can see you have negative 1, negative 2, negative 3, negative 4. It's going to continue on in the smaller direction there. Same thing over here, 1, 2, 3, 4, and it would continue on 5, 6, 7, and 8, and so forth. Okay? You can see note means continuing without end. Okay? Taking a look at the graphic organizer here. Okay? Something to think about. We have the word integer in the middle. Okay? So one of the things that it's asking you to do is to describe it. Okay? So think for a minute, how would you describe the word integer? One of the things that you might think of is for the simple fact that an integer can be a whole number and its opposite. Remember, your whole numbers are going to start at 0 and be positive. 0, 1, 2, 3, 4, 5, 6, 7, and continue on. The opposite of those would also be the negative. So negative 1, negative 2, negative 3, negative 4. So if I was describing it, that would be one way that I would think of it. When you take a look at picturing it over here, what they've done is they've given you a number line that has been labeled with the integers below. Please note that when they are describing these or picturing it, they are drawing them where your dots are specifically on those tick marks on the line. Please make sure when you draw those that you do not put your points above. Okay, sometimes we have people that will put them above. Please do not do that. Okay, make sure that your dot is below and actually on the line. Okay, examples of integers that you might see. Again, if you think about at the top the examples that they had given you, but some examples you may write down. Again, you could have a negative 5, a positive 8, a positive 12, a negative 2, 0. Okay, those would all be examples of integers. Non-examples that you might see would be anything that would be a fraction, okay, or a decimal. Okay, and again, we're looking at non-examples. So those are numbers that you see that are not integers. So fractions like 1/2, negative 2/3, or decimals such as 0.5 or 0.5, 0.3 repeated. Okay, those would be non-examples of integers. Okay, one more thing that I would like you to take a look as you are on page 191 in your book. Okay, they're giving you an example here of a snowboarding half pipe that is 5 meters below the top. And one of the things that we're going to have to do is to describe or write an integer that describes a situation. So as I take a look at this, if it says 5 meters below, okay, your key word in this is going to be below. When we think of below, we're thinking of going down, or we're thinking of a negative number. So if it's going to be below, and I'm talking about 5 meters below, my integer that I am using to represent this position would be a negative 5. Okay. Let's go ahead and move on to the next page, 192. Okay, first thing is going to be identifying and graphing integers. As I had talked about before when you were looking at your graphic on the first page, one of the things we had to do was graphing integers. So you're going to see they're going to give you a number line. Sometimes you may have to create your own. One of the things that you're going to want to remember is start with 0 in the middle. Make sure as you move to the right, your numbers get larger. As you move to the left, your numbers should get smaller. Okay, always remember that as a rule of thumb. Your negative integers are going to be less than 0, and again, they're going to have your negative symbol in front. Positive integers are going to be greater than 0. You do not need to put the plus sign in front of those when you create your own number lines. Okay, and you can continue reading through that. Examples, they have examples for you that I would like you to read through as you're looking at this lesson. Now, take a minute and look at these got it problems. Write an integer for each situation. They are giving you 2 situations. Okay, please be considerate of keywords such as above and below. So take a minute, write down the integer that you feel best represents those situations. As we take a look at letter A, we can see it says 6 degrees above normal. When I think of the word above, I think positive or going up. So if I'm going to write an integer that represents 6 degrees above normal, we should have put down a positive 6. You can put a plus 6 in front of it, or you can just leave it as 6. As we take a look at letter B, 2 inches below normal. Again, when we're thinking below, we're thinking of something that is going down, or we're thinking of a negative number. So 2 inches below normal, we would use the integer -2 to represent that situation. So again, one of the objectives for today is going to be that you're going to be able to write an integer for each situation. Those are a couple examples of that. Okay. Taking a look at the next section, you're going to be graphing your set of integers. In this case, they give you the example. Notice that they're in brackets, so we're talking about a specific set of numbers, 4, -6, and 0. So you can see down on your number line what they've done is they've plotted 4, they have -6, and they have 0. Please note that when you are drawing your number lines, make sure that they are evenly spaced. If you decide to count by 1s, that's fine. If you decide to count by 2s, not a problem, or 4s or 5s, whatever is most convenient, but just make sure that each hash mark or each tick mark represents the same amount each time. Okay. On the top of 193, they're asking that you graph each set of integers on a number line. Okay, so please right now draw a number line for letter C, plot those 3 points, -2, 8, and -7. And then for letter D, draw a different number line and plot -4, 10, -3. Taking a look at the got it problems for the next set, letters C and D. Again, we were graphing each set of integers on the number line. So what I have chosen to do here is I ended up counting by 2s. We're looking at a range of numbers of 8 to -7, so quite a variety of numbers there. So again, I chose to count by 2s. So what I did was, as you can see here, I have -2 plotted. I've got a +8, and then -7 is halfway in between -6 and -8, so I have those marked. Again, please noting that those dots are on the line, not above it or below it. Numbers are listed below it as well. Taking a look at letter D, okay, I've got -4, +10, -3, halfway in between, and then a +7 there. Okay. If you do need some more help with those, please check out the tutorials, as there will be some more examples on there of graphing integers on a number line. The next important piece in lesson 1 is looking at the absolute value. And the absolute value is going to be something that is new. Okay, the one thing that I would like you to highlight or to be aware of in this lesson is that the absolute value of a number is the distance between the number and 0 on a number line. So please highlight that in your book. Key word in here is going to be the distance. Okay, when you're thinking absolute value, basically we should be thinking the distance away from 0. Almost want to think of it as a game-like situation. So for example, if I talked about the absolute value of 2, so that's going to be written using straight bar, 2, and another straight bar on the side. So what I'm thinking is I'm going to start at the number 0, and I want to ask myself, how many places would I move to get to 2? 1, 2. So the absolute value of 2 is going to be 2. You can see they've given you a couple examples here. The absolute value of -5. So -5 is way over here. Again, I'm going to start at 0. 1, 2, 3, 4, 5. I'm moving 5 places, so my absolute value is 5. If it's a +5, absolute value of +5, again, I'm starting at 0. 1, 2, 3, 4, 5. It's going to be 5 places away. Okay, another example could be maybe we have the absolute value of -12. So I'm thinking to myself, if I start at 0, how many places would I move to get to -12? And that would be 12. Okay. Example 4 gives you an example of the absolute value of -4, and you can see how they thought of that. Example 5 is a little bit different because here they're looking at an actual expression. So you want to ask yourself, what's the absolute value of -5, or how many places away is 5 from 0 on the number line? Okay, so -5 would be 5 places away. So I'm technically thinking 5 minus your absolute value of 2 would be 2. So 5 minus 2 would give us 3. Take a minute and go ahead and try E, F, and G. Let's take a look at Got It problems E, F, and G. Absolute value of 8. So again, how many places is 8 away from 0 on a number line? So it would be 8. Here I'm taking 2 plus the absolute value of -3. So 2 is the same as 2 plus -3 would be 3 places away from 0 on a number line. So I put 3. So 2 plus 3 gives me 5. Looking at example G, -6, the absolute value of -6 would be 6 minus 5. 6 minus 5 is 1. Putting it into perspective or a real-world situation. Example 6, we'll take a look at this one together. Nick climbs 30 feet up a rock wall and then climbs 22 feet down to a landing area. The number of feet Nick climbs can be represented using the expressions absolute value of 30 plus absolute value of -22. They have a positive 30 in here because they are going up 30, which would represent a positive number. They have a -22 in here because going down 22 feet would be a negative. Again, we are looking at how many feet he climbs all together, so that's why they're in the absolute value symbols. So the absolute value of 30 would be 30, plus the absolute value of -22 would be 22. So when I add those two together, Nick's going to climb 52 feet. Go ahead and take a moment right now and take a look on page 194. I would like you to do practice problems 1 through 7 for me.